Hi, welcome back to the next video where we will formally run through the formulas, the expressions that are commonly tested in this chapter. So I hope that so far you have an understanding what we are going through, because if you don't understand, please go and watch the previous video, right? Because from here onwards, things start to get a little bit more complicated. But at least for this video over here, you have already gone through this previously, but I'm just going to formally go through it again, right? Which is what is the general formula of a sequence. So I mentioned this a couple of times in previous videos. This is still a formal section that we need to go through. As a recap, what is a sequence? A sequence, again, is an ordered set numbers, which means, let's say this is a sequence, is a set of numbers over here that can either be finite or infinite, right? So it can be finite or infinite, right? It can be either one of this. So you can have a sequence that basically 1, 2, 3, 4, 5, right? It ends here. Or you can have a sequence that basically just 2, 4, 6, 8, 10, and then it goes all the way perpetually. So you don't need to worry too much about identifying whether it's a finite or infinite sequence, because the question will tell you, right? The question will actually restrict it for you. Like, they'll tell you whether it's a finite or infinite sequence, because the question has to tell you. If not, there's no way you're going to figure out, right? That's it. Since it's an ordered set of numbers, right? The word ordered implies that every in the sequence must follow a rule, right? But why does it imply that every term in the sequence must follow a rule? Because in order for them to be ordered, we must know what is considered as in order, right? And the only way for us to consider whether something is in order or not is to follow a rule, right? Because the rule will essentially tell us whether this term is in the right position or not. So this rule can also be generalized to be said as the general formula of the sequence. And note that every sequence has its own general formula, right? Because my sequence and your sequence are going to be different, right? So the sequence or the general formula is unique to the sequence. So you can see over here, let me just put this as A, let me just put it as B, right? So for A, what is the general formula of the sequence? What can we observe from the pattern over here? We know that this is T1, T2, T3, T4, T5, right? Because they are in order already. Same for below, this is T1, T2, T3, T4, T5. So this whole chapter is really a lot of number patterns. It's something like you did in secondary 1 when you were just 13 years old, right? And for A, you can see the pattern T1, T2, T3, T4, T5. Even though it's a finite sequence, every sequence, whether it's finite or not, will have its own general term you can use, right? But for finite sequence, the general term, the end value will be capped. Like, it cannot go on perpetually. So we know that this is 1, 2, 3, 4, 5. Therefore, we can say that Tn will just be n, right? Because it's the same number. But then n over here will be between 1 and 5. So there's a cap on this, right? Just note that it's a cap because this is a finite sequence. So there's a cap on the n's value. But let's say for B, I'm just going to draw it here. For B, what's the difference then, right? For B, then this is where you realize that for B, it goes on perpetually, right? So this is T1, T2, T3, T4, and then it just goes on and on. Now, this over here is 2. It starts off with 2. Now, T2, this is 2 times 2, right? Which will give me 4. Now, T3, this is 2 times 2 times 2. I just realized that. Let me adjust this. Okay, so let's just call this 16, call this 32. Okay, just for the sake of this demonstration, right? But later on, the bottom few questions, you will actually try out many different kinds, okay? But just for this demonstration. T4 will be 2 times 2 times 2 times 2, right? And then you realize some sort of pattern here, right? This is 2 to the power 1, this is 2 to the power 2, 2 to the power 3, 2 to the power 4. And then it goes on perpetually. So for the Tn term, it will just be 2 to the power n, right? Because there is some sort of link between this number, right? This number, right? They are all the same. So once you observe the pattern, then it becomes very easy to figure out what is the general term. And for this n value over here, right, there is no cap. So this n value can literally be any positive real integer, right? So note that for this one, because it's an infinite sequence, there's no cap on this. Okay, so this is the concept behind general formula of a sequence. Every sequence, whether it's finite or infinite, has its own general formula, and how you derive the general formula is simply just observing the pattern of the sequence. Okay, alright, so let's go through these questions. Make sure to pause this video to attempt the questions for yourself. We will attempt it together right now to figure out how do we derive the general formula of a sequence. Now, let's start with A. A is the most straightforward. Okay, but before we do that, just know that since this is a sequence, it's ordered. That means all here are T1, this T2, T3, T4, T5, right? Same for all the bottoms, all the other sequences. So for A, you have T1, T2, T3, T4, T5, right? The value over here is 1, 2, 3, 4, 5. So you can very clearly see some relationship between them, right? And it's very clear to see that Tn will just be n, right? Where the n value, since this goes on perpetually, the n value can take on any real positive integer. And that's why the answer over here is n, the element of the real positive integer. Now, for B, what's the pattern you see? The first term, go on to the next term, is just a multiple of 3, multiple of 3, multiple of 3, right? So if I were to write it out, T1, T2, T3, T4, T5. So the way that I like to present my working to myself to make it very clear for me, what is part of the general term and what is not part of the general term, or rather how do I derive the general term, would be to write everything with the same number. So this is 3, this is 3 times 3, this is 3 times 3 times 3, this is 3 times 3 times 3 times 3, this is 3 times 3 times 3 times 3 times 3. So this is 3 to the power 1, this is 3 to the power 2, 3 to the power 3, 3 to the power 4, 3 to the power 5. And then from here, it becomes very easy to see the pattern. And what exactly is the pattern over here? So you can see that this number and this number is the same. 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 And then this number and this number is the same. So if we carry on with this perpetually, because we see that over here is a triple dot, we know that eventually the Tn will just be 3 to the power of n. Since it goes on perpetually, your n is also a real positive integer over here, right? So that's the answer for the next part. Now the third one over here, the way that you actually spot the general term may not be so obvious, but I think by the time you reach this level, you should have some sort of sensitivity towards numbers, right? And you can see that if you look at all these numbers, they seem pretty familiar. And why is it that they are familiar? It's because they are all just squares of the number. So this is also considered a sequence because it's still in order, right? There's still some sort of rule that governs the entire set, right? And you can see that for T1, T2, T3, T4, T5, these values over here is just 1 square, 2 square, 3 square, 4 square, 5 square, right? There's still some sort of rule that governs all these, right? And since that there's still a rule that governs all this, it's still considered a sequence. And eventually, when we reach Tn, it's just n squared, right? You can see the pattern, whereby n is a real positive integer as well. So for part C, it's not so straightforward as A and B, but by the time you reach this level, you should have some sort of sensitivity towards the numbers already. And then for D, yeah. So this is where it gets a little bit more interesting, right? Because there's some sort of alternation. So negative, positive, right? So how do we actually work this out? So this is where remembering this basic concept in math actually helps a lot, which is, if you recall, if you square a negative, it becomes positive, right? And just like that, this is T2, this is T4. When the power, or rather when the term is even numbered term, so the second term, the fourth term, 2, 4, they are all even. It is all positive, which means that it fits what we already know, right? Because if I take -1, I square it, it becomes positive. When I take -1, I raise it to the power of 4, it also comes out as a positive. So how do we generalize this? So again, we can write it as T1, T2, T3, T4. So this is, let's say, -1 times 1. Of course, we can write this as -1 times 1. And then this one, we can write it as -1 squared, right? Then this one will become positive. And then here becomes 2. Here will be -1 to the power of 3. And because it's to the power of 3, it comes out as negative still, right? And then this one is just 3 over here, right? And then 4 will be -1 raised to the power of 4, which comes out as positive, which fits the sequence that we have above. And then here is 4 because it matches. So at the end of the day, that when here is 1, we get that here is 1 and here is 1. When here is 2, we get that here is 2, here is 2. When here is 3, we get that here is 3. Here is 4, we get that here is 4. So in general, right, when it's n over here, right, Tn, we get the case of -1 to the power of n times n, right? And in this case, since this is an infinite sequence, that means it does not end, we can also say that n is a positive real integer. And that's why the answer for these 4 questions is as such over here. Okay, so I hope that you enjoyed this practice session of deriving the general term. Let me know if you have any questions in the comments below. If not, in the next video, we will actually be talking about the convergence and divergence of an infinite series. So things start to get a little bit more complicated from here onwards already, but rest assured you will be able to catch on. Okay, if not, I'll see you in the next video.